As awesome as sprint car racing is, one area that the sport isn't renowned for is technology. For example, look at how a Formula One steering wheel has gone from a ring with 3 spokes to this thing. Whereas a sprint car steering wheel has also started as a ring with 3 spokes to now still being a ring with 3 spokes. Anyway, this is what makes Flylite Technologies and their innovative sprint car racing products so fascinating. For years, sprint car teams have had limited options when it comes to panels. Either they use fiberglass panels, which are cheap but not as durable, or carbon fiber panels, which are strong and light but expensive and difficult to repair. Steve Rowell, a former sprint car driver himself, created Flylite Technologies to provide drivers and teams with a market-leading option that ticks every box. In this video, Steve goes in depth on the Flylite product, explaining the complex process of how it's made, why he believes it's the future of sprint car racing panels, compares his product to other more common materials, and much more. Before we get into it, I can see that the majority of the channel viewers haven't subscribed yet, so just click that button down below and you won't miss a vid. Also, Sprint Car Hub is giving away 2 hats to our viewers, so look out for the info on how to win towards the end of this video.
Hi, I'm Steve Rowell from Flylite Technologies. This is our factory here, and yeah, we're just sort of going to go through what our processes are and sort of what we do. So there's myself and 3 other guys. We're on Tweed Heads, just south of the Gold Coast. I raced myself, and then after finishing uni, wanted to get into manufacturing. So I started manufacturing carbon fiber sprint car panels, and then it all sort of just grew from there. And you know, I was wanting to work into a field that turned more into like mass manufacturing using digital computer modeling and CNC machines, and carbon fiber is sort of not the right sort of industry to be going down that pathway in because of the intensive labour requirements of it. Got into the vacuum forming field and then sort of worked on designing a particular material to fulfil the requirements of sprint car racing as an alternative to fiberglass and carbon fiber. Products that Flylite make obviously are the sprint car panels, but then we manufacture a large variety of other things now. This was a great proof of concept of what we're wanting to get into, and now we do manufacture lots of other things for lots of other companies, and primarily we try to drive towards the automotive industry, but we do a lot of other commercial products and health sector products and whatever. Learning this whole process has been, quite a journey. I guess it's sort of taken about eight years, I suppose. I started the whole deal. Learning right through from, and that's something that we offer, right from the CAD modeling stage or rough design stage, right through to packaging, everything. Starting in the carbon fiber game really was a good thing for me to learn, all the processes of that and the pros and cons, and then being able to take it to sort of another level of using all CNC machines to manufacture everything is sort of where it's led to. The main process that that's what the industry is called, is vacuum forming. So vacuum forming is a type of advanced material manufacturing. In a nutshell, what it is putting an extruded sheet of resin, whether it be a plastic, some sort of an olefin, foams, there's lots of different vacuum formable materials, into an oven. There's lots of different types of ovens, and then it comes back out over the top of a mold, and then it uses vacuum to suck the malleable material over the mold to where it then cools down, becomes hard, and pops off the mold, and becomes a product. One sprint car panel kit, that's not the way I look at it. So I manufacture large batches at a time. So I do batches of 120 kits at one time, and I'll do all of the noses, all of every single panel. So the forming cycle for each panel might be, depending on lots of things, variables, anywhere from like 6 to 10 minutes, and then anywhere from 1 to like 4 or 5 minutes to trim the panel out, and then that panel's done. So maybe like 1 panel kit per hour and a half, something like that. You can extrude them in different colors. However, the cost of manufacturing is higher than black because there's a lot of other processes involved in making all of the ingredients a natural or neutral color before adding the pigments. So black is obviously the easiest for us because the material is two types of resin integrated, filled with fiber and metal powder. So to be able to make them a different color, it's a lot more complicated and a lot more cost effective to just make them black. There's lots of different ways of making fiberglass panels. So a fiberglass panel is, generally speaking, a wet resin system. So it'll be a resin that's either a polyester, a vinyl ester, or an epoxy, all of which have different properties, and all of which have different price ranges. And then there's your matting or your fiberglass filament that you're adding in to make the part a bit more structurally sound. Again, there's different materials that are there. And then that's all wet laid. So you have your mold, you put your gel coat down, put some resin down, inlay in your matting, different types of matting, different types of resin, and then you just layer it up, 1, 2, 3, 4 layers thick, whatever, and that makes your panel. Carbon fiber is totally different again, and there's different ways of making carbon fiber panels. So the first way is to do a wet laid carbon fiber panel, just like you make a fiberglass panel. The properties of that aren't really much better than a fiberglass panel, other than sort of cosmetics. They're a little bit stronger, but other than that, not really that much different. And then you can go down infusion. So you're putting the same material into the mold dry, and then you put it inside a vacuum bag and then suck the resin through the bag and over, through all of your material, and then let it set, and then you have a finished product that once you pull it out of the bag. And then there's autoclaving. So autoclaving is where the material already has the resin impregnated into it, and then that material is laid onto the mold, vacuum bagged, and then put into essentially a giant compressor vessel that both evacuates the air out of the bag, puts pressure onto the outside of the bag, and then it heats, it applies a lot of heat to it to set the resin. And then you can pull your product out of the bag, and then that's the other way of having a carbon fiber product. And then our stuff is an extruded sheet with a thermal reactive resin, so it's a totally different type of resin that gets soft as it's heated up and then goes back hard as it cools back down. And then it has a very high temperature range, so we heat it up very, very hot, pull it over an aluminium mold, and then as it cools back down, it's set into its shape. Yes, I am the only person making them in the sprint car field. In the late model game and the sedan racing game, there are people making vacuum formed panels, like all your late model noses and bonnet scoops and whatnot. Material wise, totally different though. They're using, without going really into depth of what they're doing, but yeah, totally different resin system and totally different properties. They're a lot more flexible. Yeah, it's just completely different material. The reason they're so strong is it's every single system of the resin and how it's all working together is sort of designed for the exact properties of sprint car racing. So we're using two types of the thermoplasty resin that have extremely high yield values, so they're quite stretchy. The issue with that is that they lose their rigidity, so they're not as stiff. And then to increase stiffness, which is what we do differently to what other people in the late model game and whatnot are doing, is we're adding filament into the resin. So we use metals and carbon fiber filament in powder form to basically add tensile strength and rigidity, so stiffness. And then our material is also capped, so it's capped with a different type of resin again to give it its high gloss finish. Essentially, exactly the idea behind the thing is to have something that isn't as expensive as carbon fiber, and we get our costing down because we do large batches at a time. Not as expensive as carbon fiber, but comparable in strength. In some ways, a lot stronger than carbon fiber, but be more price competitive to the fiberglass type realm, to really give teams an option of when they're out on the road, they're not having to fix panels all the time. Back in my days racing, fiberglass panels, they broke the most, and depending on what type of panel you were using, but they're fairly easily repairable on the road and whatever. And then you go down the pathway of carbon stuff, which can be a little bit stronger depending on what type of carbon you're using. Yeah, a bit stronger, but then exponentially more difficult to repair, and especially out the road where you're away from cities and whatever, the chances of having somewhere that can fix them properly is pretty slim. So the point of our panel is to be something that's a lot more durable, especially for the people out traveling and whatever. The weight differences, again, totally vary on how they're manufactured. So in fiberglass, you might be looking at, for a body kit, once it's trimmed for a car, anywhere between sort of 12 and 9 kilograms, depending on whether it's, a chopper gun's been used or if it's hand laid, how much resin they've used. Carbon fiber, again, there's a bit of a range, but around like 7 kilos for a carbon fiber body kit. And we've tried to sort of emulate the lower end of fiberglass. So we're around sort of between 10 and 9 kilos by the time they're trimmed up for a car. Cost differences, so again, there's such a large variation in fiberglass. So if fiberglass is just made with like a chopper gun, they're really able to pump them out pretty damn cheap because the materials are so cheap and the labor's not too intensive. You're just sort of rolling them out after you've sprayed the materials in. And then trimming them out, of course. A fiberglass kit might be somewhere in Australian dollars, like $700 to $1,000, something like that for a kit. Our stuff is $1,500 for a kit in Australian dollars. And then carbon fiber kits, again, they range massively because you can go right through from a wet laid carbon fiber kit, which might be around that $1,500 mark as well, all the way to autoclaved kit. And an autoclaved kit, you're looking at many thousands of dollars in Australia, maybe $3,000 or $4,000 for a body kit. Nick Speed with the East Coast Pipelines racing team, he was the first person to even trial stuff before we were even really manufacturing, using some stuff. And he's been using them ever since, and I think he's still using the first body kit, the first body kit he's ever used. I think he's only, I don't think he's really broken much or really used up any stuff. I guess that was probably 5 years ago, we were starting with this sort of technology on the stuff. Since then, it's countless. We're doing a few hundred body kits a year, so lots of teams are using them. In terms of manufacturers, yeah, we're more than happy to sell to any chassis manufacturer. Rising tide floats all ships. We're not in the game to sort of take work off anybody at all. Whatever people want to do, if chassis manufacturers want to use our stuff, I understand that it might be out of the realm of possibilities for a chassis manufacturer to go and make these themselves. So we would never be in a position where we'd say no to a manufacturer. There was a lot of sleepless nights. I guess for the first year, it took a year to develop anything. Like, it was one full year of work before I even had a panel. So yeah, it was quite an investment in both money and time to sort of have something that may or may not pan out. But yeah, it's all worked out pretty well, and and the proof of concept worked, perfectly. It's doing exactly what it's supposed to do, and that has, led us into many other industries now. There's always continual improvements. We're doing, because we do such large batches. Each batch we do make small changes to the material each time, whether it be material composition. It's a composite, so there's different amounts of different materials throughout even the thickness of the product. And then we can alter weights, thicknesses, all that sort of stuff. So we're pretty much every batch we're making tiny little changes that we think might make it a little bit better. And then obviously producing more molds and whatever. Kind of the way economically, it's around every 2 to 3 batches that we can sort of afford to start to make changes to different designs and whatever. But if you do it cleverly, you can do it not at such a big expense. Like having a universe. So for us, we have a universal panels. So we have a dash, hood sides, arm guards and whatever that can be mixed up with different panel designs. So we have 2 different hood tops that can essentially be using the same hood sides. A dash that uses 2 different types of hoods and stuff like that. So that can sort of help cut down costs to have new shapes and new advancements along the way.
All right, people, I said at the start of the video that we'd be giving away 2 hats. So to give yourself a chance at winning, all you have to do is comment "I love Sprint Car Hub" in the comment section below in this video, and we'll reply letting you know whether you've won. Oh, and you can enter as many times as you like, so get commenting.